Okay, so this is a presentation which can be considered as an extension and further explanation to whatever Baluragi has presented prior to me. So I'd like to start my presentation with a very big picture which shows the artistic view of universe. And I just want to tell the audience that we are just a small dot which is not even visible. Our Earth is a small dot on such a big picture, and that humbles us and also challenges us to explore for the better understanding of mankind and improving the life of mankind. So, all the space exploration programs, they are driven for the betterment of mankind, and there are other aspects which I will tell you. So, I would like to start a little bit differently. So, what do you know about the sun? So most of us will say that okay, it is our nearest star, and all of the planets move around it. And this is the picture generally emerges in our mind when we talk about sun and our solar system. Now we worship it because this is the source of energy, and the existence of life on Earth solely depends on the sun. And we have a large mythology about sun, different stories. But the question comes whether this supply will be there forever. So the answer is no. The nuclear fuel which is there on Earth, which is the source of energy, once it gets exhausted, there is a very scary situation which is emerging. So what is that situation? The currently the sun's age is around, it's a middle-aged star, and it's about 5 billion a year old, and currently it is giving energy very bright, but as the energy, the solar fuel exhausts, this is going to die. That is about 12.5 billion years of age. It's a very large scale to be worried for as of now. Okay, but the question will always be there that if that phenomena happens, whether we are ready to accept the extinction of human race. So if you look at the picture on the right top, currently Earth and Mars, they have the right temperature because they receive right amount of energy, neither too less nor too high, so that the life which is of our kind, the mankind and the plants which are here, they can definitely survive provided other uh, water and oxygen, all those things are there. But once the sun comes to the end of life, the inner planets will be definitely, two planets will be swallowed by sun, and the Earth and Mars will represent currently whatever you are seeing, the Mercury and Venus. And this situation also will be there only for 500 million years. So ultimately, the habitable zone in our solar system will shift, but that also is not everlasting thing. So one of the reasons for going for human space exploration, there are many, but one of this which you can think of the ultimate reason is we need to find a new home beyond Earth. Another thing is, and we have to develop the technologies to reach there, and we need to develop the technologies to sustain there. So the current human spaceflight programs are a very small step towards this larger goal, which whole humanity should strive for. Now, when we talk about the challenges, because if you want to develop the technology, you should know the challenges. So we need to understand about the space. The space is a unforgiving place, everybody knows. Surviving environment is very difficult, and technologies needs to address this also is very difficult. So if you look at the challenges, there is no air, it's a deep vacuum. We effectively don't feel any gravity. because it cancels out extreme temperatures, lot of charged particles shooting here and there, the radiation from sun and the galactic sources, they are coming, and a lot of space debris because of the man-made satellite as well as the other uh, cosmic particles, galactic like asteroids and meteoroids. All those things are the threats. So, in nutshell, if you summarize the challenges, there is a acronym called RIDGE, RIDGE. So, because we are talking about humans, so our main effort is what are the problems for humans. So the radiation is a problem. I have the slides to explain what are the problem. Isolation is a problem. You can't sit in a very small room for the years together or even for the days. Distance from Earth, because Earth will remain the control point for the next few hundred years of human spaceflight missions. So the distance from Earth, because you cannot attend the emergencies immediately. Absence of gravity and the hostility because of the temperature and other things. So these need to be addressed. So now we are talking about only the challenges which are posed because it has to be the manned space mission. Whether it is a short duration or long duration space flight, there are effects on all the parts of body. So in nutshell, everything degrades. None of our ability is going to increase once you go into the space, because of the fluid shift. You get the motion sickness, your muscles degrade, your bones degrade. Because of the radiation, you run the risk of cancers because of radiation also, and because of the microgravity, your heart starts behaving in a very different way, which may sometime lead to the failure of heart. Your immune system behaves differently. So these are the challenges of the human space flight. But despite of all this, why would you like to do it? That is the big question. So the answer is, if you look at the benefits of the uh, human space flight program, whether we are able to beat the sun's death or not, but in the near term, there are many benefits, like there are medicines which can be developed in space which cannot be done on Earth. There is an opportunity to test certain medicines in space, because the astronaut health is it is fast degeneration. So in Earth, there are diseases where you have slow degeneration. So you are getting an accelerated atmosphere. You can test certain medicines. Material science, because there is no gravity, the fluid mixing is very uniform. You can grow the crystals which are not possible to grow because of the presence of gravity and convection on Earth. uh, then you can develop you can improve your robotics technology, very efficient energy system. So one of the challenge in the long duration human space flight is how can you make a technology which will give you self-sufficient. Self-sufficient means you have only X amount of resource and you have to use the same resource, a true recycling. 100% recycling of resource has to be done if you want to really go for a very long duration space flight. So all these things, and beyond this, international cooperation, then the inspiration to the students and the researchers. So many things are there. I will encourage you to go to the internet and read further. Now, uh, everybody will ask, what is the proof? You are just telling that these are the potential benefit. But there are few examples I am trying to bring it here. So the space flights have given more than 30,000 technologies which are commercialized, which were developed only because of the space flights, including human space flights. So sunglasses, computer mice, magnetic resonance imaging, uh, miniaturization of your medical systems, smoke detectors, quartz watches, barcodes. There are many things. Space shuttle fuel pump is a spin-off. Their spin-off is helping children to heal their hearts. Then one very interesting spin-off is Moon Shoe. So that to develop a low shock footwear, there were technologies, there were materials developed only for the moon landing, and that has caused the revolution in the. So you get the sports shoes only because of the moon mission. So these are some of the examples I tried to brought. Now coming to the space journey. So there are three categories currently all the agencies are working on. One is near our home planet, that is the space station. I will talk about it later. But why we are doing a space station? Because we want to go to moon, we want to go to Mars. So this is the intermediate stop where you mature your technology, you do all your experiments, and then move towards the farther distances. Now, once you go to the moon, the new challenges will come because there is no air. So how do we do that? How do we stay there? More radiations and so many other things. Then the journey to moon is still viable, and it has been done because it is around 4 to 5 days. But the journey to the Mars is much difficult because it is going to be a 6 month long journey. So now that is the great challenge for going for the human missions. So these are the things which you have to address. Now, since the topic is the Bharatiya Space Station and what are the other space stations which have evolved. So if you look at the history of space stations, uh, earlier stations were monolithic, means a single module launch and then the self-sufficient to survive. So those monolithic space stations, there are examples like Russians started first. So they put the Salyut station in orbit, and it's about 20 ton, 90 meter cube class of station. And it could sustain for 6 months, about 11 crews spent 23 days. Soyuz 11 was the crew vehicle which docked with it. But that time, not much of the experiments were done inside. Most of the experiments were outside there. They installed solar telescope, X-ray telescope, and spectrometer and all. And it is known that they have done some military observation also, imaging of Earth. Now coming to the, of course, the Cold War era. So the US also launched their own station, that is Skylab. It was a much bigger station, and there also it was in orbit for 6 years, and there they focused more on the research inside the station, including medicine and some sun and earth observation and habitability design. All those things were done inside. Now the stations started evolving. Then it's turn of Russia. So they came with a much evolved station. And this was the first modular space station where the different modules were launched at different time. They were assembled in space through a docking technology. And this was much bigger size, about 350 meter cube, 250 tons of the station. And again, the focus shifted to the biology and other advanced experiments on the station. Now, ultimate thing came. Now by that time, everybody realized that if we want to be a bigger station, we need to pool resources. We need to go for the international collaboration. So ISS was born. So ISS is a very big multi-modular station, and it kept on evolving over time. And about 1000 meter cube, 420 ton, and it can house more than 6 crew. And this station has transformed the future of human space flight, because this has given too much of data, too much of information, and too much of confidence to take these technologies further. Now, Chinese also, they started a bit late, but they launched 2 stations which were single module, experimented it for a short duration and deorbited it, and ultimately came with the Tiangong space station, which is a 3-module station. And there are also a lot of microgravity experiments are being done. Beyond the national space agencies and government, there is a new trend in the current era that the space stations are being built by the private players. So there are two examples of this. One is Big Love, which is a next generation commercial space station. And it is a kind of inflatable module. In fact, they tested their inflatable module by docking with the ISS in 2016, and they are working towards the full-fledged station. Now, Axiom is another company which is truly talking about a viable solution for a long duration LEO station, and they aspire to start building the station now till 2027. These are the baseline plan. We have not seen the first launch yet, but they are working towards that. But this is very similar to a multi-modular space station, which is targeted to support the experiments as well as tourism. Now, this is just the summary over the timeline, and where you can see that the stations evolved right from the 80s to till now, and there is a sustained plan for taking it further, and that is where we entered into the game, and we are trying to talk about our own space station, which is called Bharatiya Space Station, or BAS. So I will talk a little bit about this. Baluragi has already talked about this, that what are the objectives. I will not repeat the objectives, but I will tell what gave us the confidence to go for it. So it is not new that we are working on the technologies which will ultimately lead to the sustained Indian presence in the low Earth orbit, and ultimately leading to the Indian landing on Moon. So everything started from in 2007 when the space recovery capsule experiment was done, and to the surprise of all of you, we in fact carried the microgravity experiment on them in this 2007 module. Later on, we started developing the crew module, and we tested over the atmospheric re-entry in the KR-1 mission in 2014. Then we tested certain pad abort technologies, certain escape technologies in 2018 and 2023. And we are very close to doing our first uncrewed flight, which will also validate the various technologies, which will allow you to ferry to space station. I always give this example that if you want to go on the Everest and stay there, you need a technology or means and preparation to climb it. You should have ability to come back to the normal altitude. Also, you have to build certain technologies which will sustain you at the peak of Everest. So the Everest peak can be considered as a space station, and Gaganyaan can be considered as your preparation or your ability to climb the peak and come down. Now, coming to the BAS one, again, this is a transition from the LEO transportation to the human habitation in the LEO. Baluragi has already explained that it is a 5-module station with 3 inline modules and 2 across-line modules, with the provision of 2 Gaganyaan modules getting docked to each side of this. This is further explanation of our space station 1, 2, 3, 4, and 5, and this was anyway explained in the previous thing. So here just I want to a little bit elaboration on the different type of modules we have. So we have the base module, which will be launched first, and that is a that will have the capability of servicing, habitability, and a life support system, which is non-regenerative, means it will use it will have a stored resources the water, oxygen, nitrogen, and all these things, and manage the habitability based on that. We are also planning to put certain payload racks, which will allow the Indian researchers to do the microgravity experiments. And then slowly this will evolve to the core module, lab modules, berthing modules. And after all these things are there, we have the full-fledged stations available for lot of research in the 0G. Now, there are precursor mission planned beyond the Gaganyaan. We have another mission where the human in loop maneuvers will take place, because you have to dock to the station. Astronauts have to maneuver the vehicle which will dock to the station. So that will be the experiment in S2. Then we have to develop the autonomous docking also. So that will be probably tried with any of the international station available. Then we will launch our first BAS-1 module. And then we will launch another Gaganyaan, which will have the autonomous docking, and it will robotically transfer the cargo, maybe some experiment and some other things, and install inside the module. And this is at that time we will have the full confidence to go to the next phase of building another 4 module. So if you look at the inside, in nutshell, the blue zone is the main. So this also symbolizes the Earth, which is from the space, it looks blue. So in this zone, all the astronauts will be staying and conducting various experiments, and rest all other zones are for their consumables, for the propulsion. And the left side, it is a way to enter. You have the airlocks. And so this is the amalgamation of many technologies, launch vehicle technology, spacecraft technology, and some of the new technologies, which is called life support systems technology and human factor technologies. This is just a sequence, not much relevant for today's presentation, so I will skip this. Now coming to the gamut of the technologies. So if you look at, so as I told that it is amalgamation of large number of technologies. At the core, you can see the engineerings, which is structures, power, communication, propulsion. Then comes the new factors, the safety, emergency, life support, crew, comfort, and other things. So the safety will again involve the protection of crew as well as protection of space station from the orbital debris impacts and so many other things. So this calls for a very careful consideration of optimum balance of all the technologies. So you need a life support system. So I will always give this example that Earth, you are trying to maintain a air conditioning room. You have indefinite resource available. You can draw any amount of power from the outside and manage everything. But in the space with the limited power, you don't have any oxygen or nitrogen available from atmosphere. You have to manage from inside. So these are the things which are very, very challenging in the space. Now, there are 6 different human-centric aspects which has to be addressed while you are designing. So habitability and work environment, because crew should be able to be there and work safely, crew safety. Human factors, its ability to do the task. Then crew health management, fitness, nutrition, well-being, and the human factors in the mission planning. Right now, we in the satellites, we don't plan the human factors. You have to plan that he is not available for 24 hours. You have to worry about the sleep cycle and so many other things. Then all these things, the crew should be trained. So the crew training on the ground. It is very difficult to mimic everything which is there on space, but still you have to train them with your limited ability to mimic everything which comes in the space. So when we are preparing for BAS, the human factor is a new thing where we have to do a digital simulation of the different aspect of human interaction with the station modules, how he will enter, how he will move his hand, whether his hands are getting more strained because it is in microgravity environment. The capability is reduced. So a good assessment of all these things. If the crew has to move certain thing within the station, how it is going to be done, everything will be a big planning, and uh, you need to simulate everything, plan everything well in advance, and then only execute in orbit. For the fitness, so there is no gravity, so your muscles and bones are not loaded within a week. So you will start losing your strength. So strength has to be maintained, but you don't have a big ground for the exercise. You cannot put a big treadmill there. So even the exercising equipment and the design of exercise itself is in a technology itself. So what are the portions which needs to be stressed? So the ensuring crew health is also one of the great challenge. Then the life support system I was talking about, you have to manage, you have to scrub the CO2, you have to maintain the oxygen and nitrogen ratio, and this has to be pressurized very near to the, so you have to create a earth beyond earth. So there are two technologies, non-regenerative, which is going to store its own resources, which is going to be the in the initial BAS modules. But ultimately, we will launch a module which will make a regenerative ECLSS, which will almost recycle everything probably to the tune of 85%. So you will need resupply mission to replenish the loss of 15% resources periodically. Uh, Now I would like to just give you the flavor of few other things like personal hygiene management. So once you eat, you have to excrete. That is a human body. So in a closed environment, how do you manage that? So the space toilet also is a technology. Now, since this also will need air, now that air is a resource you don't want to lose. So can you imagine that your air from your toilet is getting flushed to your bedroom? It's unimaginable on Earth. But if you go to space, you have to filter it and use it. So the odor control also is a technology. So I'm trying to give you the flavor of different challenges. Now, food and water. So food anyway is prepared on Earth as of now till we get the technologies to grow the plant and maintain that full cycle of farming. So these are the, so how much food, what astronaut has to be has to consume. Actually, the calorific requirement in space is more than what you need on Earth. More than 2,500 kilocalories per day is the requirement of astronaut to maintain its fitness. So very special design of food is done. It has to be stored at optimum temperature, and everybody would like to have the taste. So everybody, so there is a psychology related to the food. You cannot just pop a pill of high energy and stay there. So it is a psychological requirement of astronaut to, when he is eating or she is eating, it should be earth-like taste. So that is one of the challenge. So the storage of food, warming of food, storage of water, dispensing of water, all these things are the technologies. Then there are technologies which has to be developed for the cargo transport, and this is just a typical resupply mission in the initial phases of BAS, where you have to carry the oxygen, nitrogen, then carbon dioxide scrubbing canisters, drinking water, then the solid waste tank, the crew toilet storage tank has to be removed from there, and a new tank has to be installed. So these are the things. So there are things which you have to always carry up, and there are things which you have to carry down. So the resupply missions are designed to address that. There was a very interesting story that in the Soyuz, they used to dump the waste in orbit and it used to get burned in the atmosphere. But that is no more the practice nowadays because of the different concerns. One more aspect of the Bharatiya Space Station challenge is the protecting the station from the micrometeoroid hits. Now, there the particles are traveling with the velocity of almost 7 to 8 kilometers per second. And if there is a head-on collision, it is almost, you can say that you can potentially hit a particle with a 12 to 15 kilometers per second of velocity. So if there is a puncture, everything is lost. So there are very specific design which is done to ensure that the BAS module or any space station module is safe from the debris hits. So like the man-made problems on Earth, we are spoiling our atmosphere. Same way we are spoiling the atmosphere by launching so many things in space and creating a lot of debris, which are the potential hazard for any space station because of very large area cross section. So the probability of collision increases. Now coming to the radiation protection. So now we are lucky that on Earth we have two protections available from the cosmic, galactic, and solar radiation. One is our atmosphere itself. Second is our magnetic field. So our magnetic field traps many of this radiation in the near Earth orbit. Now, this trapping is a boon for us, but it is a problem for the space stations. So, space station has to pass through these trapped particles. So, that is a one continuous radiation particles are there. Apart from that, there are flares which will come from the sun and other sources. So, the problem is twofold. So, the space station, there are very special protections to be designed. Sometimes we try to leverage on the available cushions like water, and there are certain areas of the space station which has to be shielded more than other areas. And if there is an event which is predicted for a very high solar flare, the astronauts, they have to go into that shelter. So there are radiation shelters which are designed within the space station. Now, why we are doing the space station? Because we would like to conduct a lot of experiments in the different domain. I have few slides to cover that. Now, those experiments need a very specific racks to be positioned there, and where the experiments from the Earth will go, it will get plugged. The presence of human is utilized to conduct those experiments, and then some of the samples they come back to Earth, and other cases where the data is there, the data is downloaded to the Earth. Now another part is viewport. Ideally, we would like, for the safety purpose, we would like to have all metallic station. No hole should be there, but that is not going to give a good feeling and full application. So there is a viewport, which is a quartz, a very thick quartz, very specific design, a multi-layer quartz window through which there is a beautiful view of Earth. And that is one of the motivation for the astronauts and tourists to go in space and observe the Mother Earth from 400 kilometers, which is impossible from any other vantage point. But this poses a lot of challenges in the design. I don't think that you should go and read something about the viewport which is used on the space stations. Then preparation for climbing the Everest. The way you prepare for climbing the Everest, you need to have certain physical capability, certain mental capability, certain gears which will take you to the Everest, strong willpower, and lot of training, lot of acclimatization, lot of familiarity to those situations. Exactly similar things are followed for the training of the astronauts. But these things need a very, very huge investment because you don't get the natural sites. Like mountaineering training, you have the natural sites available, you can go and do that. But for the astronaut training, you have to rig up several infrastructures, and one of the like centrifuge to give them the feel of higher acceleration, which they will feel when they are in the launch phase. When they have to do some extravehicular activity, go out and do something. Uh, that training is done underwater with a mock-up of a station with a controlled density, a large pool of about 30 meter by 50 meter by about 12 meter depth or even more. So these things are capital intensive, but they are must for the training. Uh, then there are a few other technologies. Docking any was discussed earlier. Earthing is another thing. Means you have to pick the module and change the position. That is also so a robotic arm. You must have seen in the space station the external robotic arm, internal robotic arm, then the sensors which will precisely guide you for the docking, the thermal management of whole stations, uh, then the electronics and communication. All these things are the challenging technologies. Now coming to once you have the BAS, what all you could do. So there are many things which can be done by taking advantage of four factors: long duration microgravity, exposure to space, unique view of our planet, and unique view of outer deep space. So these attributes enable scientists to do many innovative experiments, and also available of human which can do many things in a very short time. If you want to do a robotic operation of same, it may take very, very long time to do a very small task in space, but humans can do in a very small time. So that advantage is there in the orbiter. This slide anyway was shown by Baluragi, so I will not dwell on this. Now the domains for the BAS application which we are using, that we can conduct the physical science, biological science, space agriculture, astrophysics, space manufacturing, pharmaceutical research, and since astronaut is available, that itself is an object for the research, so the human research. Now the SRE, I already talked about it. Only in the lower two you see the isothermal heating furnace was one of the microgravity experiment, and other was biomimic material processing reactor. So these were the two microgravity experiments successfully conducted. Now I will come to the very recent mission, which was a POEM mission, where first time India has done in space farming. So the seeds were uh, sealed in a earth-like closed compartment, and the water was kept separately, and it was injected when we were in the micro-G condition in the orbit. And you can see within few days, 4 or 5 days, we could see the seed sprouting. And so this is the first step where the cowpea seeds were used, and this is the seed which germinates very fast. That is why it was selected. So this is a very good platform for researchers to do the further microgravity experiment. But there are other opportunities where we are collaborating with international space agencies and creating the opportunities for Indian researchers. There are opportunities on the Gaganyaan mission. There are opportunities for I already said in the BAS. We are also trying to set up the facilities which will enable the researchers to validate their experiment on ground before going to the long duration in space. And we are going to handhold all the researchers to do these things. So These are the 4 options. Anyway, the sounding rocket, where a few minutes of high quality microgravity will be enabled. Poem already spoke. Gaganyaan is there, and then the space station. Now, this is a roadmap. If any of the researcher is interested in doing microgravity experiment, they can follow this process right from the ideation to taking it to the Bharatiya Space Station. And I encourage you to be the early starter and be the part of national mission of Bharatiya Space Station. Thank you very much for your patience here.